Welcome to another episode of Software Architecture Stream, this time around with Kevlin Henney. Kevlin, welcome to the show. Do you want to say a few words about yourself?
Yes. Thank you for inviting me. So my name is Kevlin Henney. I'm an independent consultant, which is a term that covers many possibilities. I run workshops, I do code reviews, do training, I write. A mix of these things. My interests are, I guess, the detail of code, the big picture of architecture, people. People are the hardest system we ever deal with, so I find myself increasingly fascinated by that side of things. And I am based in Bristol, in the UK.
Excellent. So one thing that I always wanted to ask you is, on Twitter you're collecting these images of some error messages of some computers. So if you have such a thing, then just take a picture and mention Kevlin Henney in the tweet. But why do you do that?
Yeah, that's an interesting one, because it started a very long time ago. In fact, it started around the time that cameras started appearing on phones, and I traveled a lot, so I would just notice hanging screens in public places, train stations and airports that were not working, but I also noticed it in browser windows. There'd be problems, you get exceptions or stack traces, and I kind of take a screenshot of these, and then I would normally just put these on the screen on a kind of screensaver during a break if I was running a workshop, or sometimes integrate them into my talks. And then I started doing that. People started emailing me these error messages that they had seen and taken. And then we kind of hit the social media era, and people didn't need to email me anymore. They just started sharing them directly with me, and then atting me on Twitter. That became a thing, and I would retweet these because I thought, hey, this is kind of fun. I would again integrate some of these into my talks. And then around 2016, somebody actually said, I saw a Kevlin Henney screen. So it's suddenly, at that moment, it had got to that point where people were doing that. And so the word is kind of taken on a life of its own. And so I do this sometimes because sometimes because it's fun. And it's the idea that accidentally in software development, we create the most installation art on the planet. Accidental art. It's kind of like a guerrilla form of art. But it's also a reminder that in many cases, how much our world runs on software. And if we're in software development, we have a responsibility here. We're basically, when the world breaks, an illusion breaks there. So it's kind of a reminder of that. And it can also be entertaining. It's kind of showing what's really going on behind the illusion that many people experience on a day-to-day basis. And actually, there's an interesting public benefit side. Sometimes when people do this, they will say, oh, I'm standing at a station and I got this error message, and they will mention the train company or the station or the company that they're currently failing to order something from. And there's a reasonable chance that company will then respond and say, oh, yes, we're aware of this error. Thank you for pointing it out. Or, oh, which station was this? We want to fix it. So there's a public service as well. Somebody's going to try and fix it. So, yeah, I just started that, and it seems to have continued, and it's kind of interesting.
Yeah, I heard the story about one company that actually has a monitoring on the number of mentions on Twitter, and if it's really high, they know that probably something is broken. So there you go with monitoring of your systems. So sort of the reason why we are sitting here together is because of the Software Architecture Gathering, and you are going to do a keynote there, and I just put the discount code for that conference on the chat. So it's SAG21_EW_15, and your keynote is about incomplete knowledge. What made you choose that topic?
I think this goes back a little bit what I just said about my interest in the people side of things. I think that when people are asked to do things like estimate how long will this task take? Decompose this story into tasks or something like that. Give an estimate of when we can expect this. If we've got a major release cycle that covers every few months, then when can we expect this? But more importantly, somebody else normally wants that from us, and they want to say, oh, we'd like it by the third quarter this year. And we're being asked to do something and estimate something and provide numbers and create something. And this particularly where we are dealing with a shift in technology or a new direction for a system. We are going to be establishing new architecture. We're going to be walking out to new architectural territory. We're probably doing something that is unfamiliar to us. But actually that's the truth, is that it turns out that most of software development, and the reason our estimates are, there are many reasons our estimates are quite poor, but most of software development is about the fact that we're trying to create something new. By definition, we don't know what we're doing. That's the whole point of software development. Somebody wants something new in the world, so they ask for it. And they're not going to go to you for something that already exists identically. There may be something similar, but even if it's similar, it's not the same. If somebody comes along and says, oh, we have this system in Java, but we're moving to .NET, they're not asking for the same thing, because they've just told you the whole technical basis of the system will be different. So therefore, there is something new in it. Now, the whole point is we don't know everything about that. And the people being asked to estimate and build and to make the key decisions don't have enough knowledge. They are not operating with complete knowledge. And it's this idea that this is a normal state for being human. It's not unique to software, but a lot of the things we do in software are based on, I guess, idealizing the idea we know everything. We can know everything, and we can give you numbers, and we can say with confidence certain things. And actually, when we look closely, that's not really the truth. And actually, it's not what we're supposed to be doing. We're always operating with incomplete knowledge. And what I want to try and demonstrate is that this is not a problem, because this is the human condition. When you wake up in the morning, you do not know what you are doing that day. Okay? I mean, you have an idea. You have, as it were, a draft idea. And, we said, right, we're doing this today. And we've scheduled that in. But, we didn't know what each of us is going to say at a particular point in time. We also don't know what else is going to happen. So being human is about working with incomplete knowledge. As you enter the day, you don't know everything. So why should that be very different just from the day level to a year level? The hard part is that if we think we know everything, that's when the problems happen. It's not that we don't know everything. It's when we think we know everything. That's when we get surprised. That's when the problems happen. That's when the schedule goes off the tracks. When we discover architectural surprises. Hey, we're using a new technology with a new team, and we're having a lot of surprises. This is not as feasible as we thought it was, or it's much easier than we thought it was. We didn't know because we didn't know. So that's basic. I find that interesting, but I think that a lot of the troubles that we normally advertise in software development are to do with the illusion of knowledge. It's not to do with the lack of knowledge. It's to do with the illusion that we don't have a lack of knowledge. I think that's the harder thing.
So on the one hand, you say this is sort of what the human condition is all about. On the other hand, you're saying that this is a result of the technology shifts that we have in software engineering. So here's a question that I just came up with, and I'm not sure whether you can answer it. So let's imagine that software architecture gathering wasn't about software development, but it was about electrical engineering or civil engineering, other engineering disciplines. Would the keynote still make sense? Do you think it's something that is really specific to software development? Is that the emphasis, or is it just about us as humans, and it is something that is generic to all engineering and actually to all humankind?
I think, that's a really good question, because I think this is to do not so much that software is necessarily unique, but software has an amplifier effect. It's like the signal is always there. That the fact that we're working with incomplete knowledge, the signal is always there. But then there's something about software that distinguishes it. So software and other informational forms of engineering are distinct from physical forms of engineering in the fact that with software, we are always trying to create novelty. We're trying to create something that is new. It goes back to that point. And that becomes the main goal, if you like. So, let's just talk about not so much engineering, but just general design. And so I've got a nice pen here. In fact, I have about half a dozen of these pens lying around my desk. I like these a lot. I'm not being sponsored, by the way. I like these Pilot G2s a lot, but all of these pens are effectively identical. Somebody did some design. The design was an evolutionary design from previous designs based on flow technology that works and all the rest of it. It's an evolutionary design, but the manufacturing of it is they produce identical artifacts. When I order a pack, I'm expecting them all to be the same. Now in software, what we have is we've been able to accelerate our time frames. That's the amplifier effect. In other words, we take the kind of concerns that probably exist within other disciplines, but actually we make them first class. The idea that we're not working with complete knowledge is now much more normal. Our time scales are much shorter because we don't have logistics. There are no material. I don't have to go out and say, where am I going to get electrons from for the next build? I don't tend to think about that the same way. But also when we solve the manufacturing problem, we are left with the design problem. The manufacturing problem was solved in the 1950s with the invention of the compiler. Progressively with build systems, we get better and better at being able to deal with the bit that can be automated, which leaves us with the bit that can't be automated. Is somebody wants something new that is either similar or radically different to something that already exists. So we're constantly on a cycle of asking for novelty. And because we don't have a logistics, we don't have to wait 6 months for a piece to turn up in the kind of pure software space. For us, that makes the problem, it allows us to accelerate the time scale. So all these other disciplines, they experience some of the same things, but over longer time scales and to slightly lesser effect because some of their other concerns are elsewhere. They have to care about logistics and things. That's not part of the thing we worry about. But our time scales shorten because software is soft. We can imagine, if you can imagine it, you can probably build it. And somebody else can imagine it as well. So I think that's what makes our incompleteness of knowledge. It forces us to confront it. Whereas in other disciplines, we can actually ignore it to a much higher degree. It's okay to say, let's not worry about that. All of our projects are self-similar and the physics is self-similar on each of these. And the manufacturing is self-similar, although people are experiencing some exciting new things with supply lines at the moment. But, it took a global pandemic to induce that. But with software, we experience that locally and frequently, and I think that makes it different for us. I think that it just pushes it above a level.
Okay, I see. Also, in your abstract, it says that there were known unknowns, unknown unknowns, and unknowable unknowns. And those are slightly confusing terms, probably. So do you want to say a few words about them and how they are relevant to software architecture?
Yeah, so this is kind of originally, I think one of the most inspiring or most useful frameworks I came across for thinking about knowledge was by Philip Armour. And he wrote this in 2000 in Communications of the ACM. It was called The 5 Orders of Ignorance. And he listed, the 5 orders of ignorance go 0, 1, 2, 3, 4. So he starts at 0, which is good. And he talks about these. He says, level 0 is lack of ignorance. Basically, you know what you know. You have knowledge about what you know. Okay, so, I know that I can speak English. Okay, that's a thing that I know. I'm unsurprised by that. And I can estimate or make judgment according to that. Level 1 is where you have a lack of knowledge, but you're aware of it. I know I don't know something. I don't know how to speak or to read or to write Japanese. And it does not surprise me if somebody showed me some Japanese or I was listening to some Japanese. I am not expecting to be able to understand that. That is not a surprise to me. I already know that I don't know this. So I have knowledge of something that I don't know. Now, already we'd say, well, okay, that's great. And I can see the relevance to software because clearly software is, there's a high degree of knowledge and there's a certain knowledge that we have. how to build things. What is the knowledge? The knowledge of the technologies, the knowledge of the domain. There are things that we know, but then we also recognize there's this bit that maybe I don't know that I don't, I don't know something, but I know it. It's fine. If I enter into a new domain, I say, well, I'm new to this domain. I'm a tourist here at best. And you can formally acknowledge that up front. And that should allow you some benefit. But the problem is we tend to downgrade that. We're already entering a problem because we think it's like looking towards the horizon. Okay, the things that I see immediately near me, they're big and they're large and I can see them. Then there's things in the distance. And I know that they're in the distance, but they don't seem as important because they're far away. And that's the problem. We start demoting the things that we don't know, because if it was important, then I'd know it. There's a little cycle in your brain that doesn't help you, that basically says the stuff that I know is important. Why is it important? Well, I know it. It's kind of a very egocentric, self-serving human capability. And then there's a bunch of other stuff that I don't know. And it's not that important, because otherwise, if it were important, I would know it. So therefore, you've already demoted it. And this leads you into areas that are known, Daniel Kahneman and Amos Tversky define this as being the planning fallacy. This is the late 1970s. That tendency it's part of the tendency to underestimate the things that even when you should account for them, because you don't know everything about them, you think they're less important and you reduce that. So that's only got us to level 1. So let's just understand that the first level 0 is the known knowns, the things that I know. Level 1 is the known unknowns, the things I know I do not know. Now it gets exciting. We've already got a kind of warning that maybe our estimates and our understanding of the amount of work, but also when we're making architectural decisions, we are trying to make decisions about things that we do not yet know. Our system is not currently running. It is not currently deployed. We have never built with this technology before, or the new version, or we've never used it in this way. And we might be aware of that. But what if we're not aware? What about the level 2, which is the unknown unknowns? Now, that phrasing comes from Donald Rumsfeld, possibly his only but also surprising contribution to the world of philosophy. The fact that we don't know that we don't know, the fact that we're not even aware of this kind of thing. And if you like, going back to the kind of idea of the horizon, okay, there's things that, there's the things that are near me, the things I can see in the distance, and then there are things on the other side that I don't actually know. I'm genuinely not aware. Now, personally, as a point of view, I just mentioned languages, English, Japanese. For me, the curious thing is, I could speak Portuguese, not brilliantly. My mother is Brazilian. My Portuguese is not great, but I was not aware as a child how different European Portuguese is until we went to Portugal. And I did not know that I did not know that it was different until I arrived there. At that moment, it was a real shock. I couldn't understand people. And it was a real, I did not know that I did not know. Had you asked me, Kevlin, can you speak Portuguese? I would say, yeah, I can speak Portuguese. Can you speak Japanese? No, I can't speak Japanese. Can you speak English? Yes, I can. What about going to Portugal? Yeah, that should be fine. What do you mean I can't understand? I did not know that I did not know that. Now, turn that to software. And then suddenly we start seeing, oh yeah, there's a whole load of things that we are constantly surprised by. And this is where we reveal things like our assumptions. And I think assumptions are really interesting pieces of knowledge, because you have them in your head in one sense, but you don't know that you have them. You can't go and ask somebody, please tell me all of your assumptions, because normally you only discover assumptions when they are contradicted, when they collide with reality. And somebody says you're in a meeting, or somebody gives you feedback, or says, oh, we got this problem, or there's a concurrency, or there's a locking issue, there's a scaling issue, and you go, oh, I had assumed that. At that moment, you have discovered you had an assumption. Had anybody asked you before, you wouldn't have been able to present it as an assumption. But now it's collided with reality. You discovered you had it by finding it was wrong. You did not know that you did not know this. So that suddenly we start realizing, how much of software is in this space? Then there is level 3, the unknowable unknowns, or rather you don't have a process for finding out what you don't know. Because we can do something about level 2, the unknown unknowns. There's a technique you can borrow from Dan Terhorst North, deliberate discovery. If you start building things and you start trying things out, you increase the probability you don't guarantee anything, but you increase the probability that you will find some of those things that you didn't know you didn't know. You know, it's you know, if you don't step outside, you'll never find out what it's like to walk down the street. You know, it's one of those things. In fact, I talk about assumptions. I sometimes say an assumption is a little bit like a Lego brick that's sitting on the floor in a dark room, and you are going to go in. You know there are Lego bricks on the floor, but you don't know where you're going to step on them until you have stepped on them. And so what we're going to try and do is we're going to try and walk into that room and carefully push our feet out to find those. We know there's some there, but if we stand at the door, we'll never find out. And that's the idea of, like, that's why I tend to advocate any kind of development process that treats our ideas. Oh, we're going to use this architecture. We can use this tech. We're going to use this technology. We're going to use this stack. Treat that as a hypothesis. Now, gently walk into the room. You've got to try it, because otherwise you won't learn anything. So that's deliberate discovery can help us with level 2. Then level 3, the unknowables, you don't actually have a process. And that sounds, well, what does that mean? If I said, let's find out, how would you find out? And I think we're currently living in a pandemic. So I would like everybody to go back to all of the project roadmaps that they had in 2019 and see if pandemic in 2020 was on any of them. Because the point with that one is that there was no process that you could have run to have discovered that was going to happen, except the process of time. That, you know, and that also has an impact when we talk about, when people say, oh, we're doing this because it'll be useful in future. Will it? Well, until the future arrives, I can't know that. We're going to prioritize by business value. You don't know the business value until something has been deployed and used, and then you look back on it. You cannot say what the business value is. We have no process for defining business value in advance. It's called an estimation process, but that's not actual business value. That's estimated business value. So it turns out this is hugely important to us, because a number of decisions that we make are based on things that actually we cannot know until the future arrives. And then there's level 4, which is the 5th one, meta-ignorance. You don't know about the 5 orders of ignorance. Well, we've solved that one, which leaves us with 4, which is the known knowns, the known unknowns, the unknown unknowns, and the unknowable unknowns. So that, if once you have a way of classifying the things you know and don't know, that doesn't solve anything, but it does allow you to separate things out and say, well, what are we thinking about this? You know, what can we do with this? Is this something we genuinely know, or is it just a feeling? You know, do we have evidence of this? That starts us asking the right questions.
Okay, and I think there is a very clear impact on agile processes, because if you want to deal with these different level of unknowns, actually adjusting to what you find out is very important. And you also mentioned that there is, if you want to support business value, for example, and that is the foundation of your architecture, it also has a very clear impact on architecture. And I also thought about legacy systems where you might not know what is going on there, and you need to discover it. And, you know, surprises like the pandemic might also have an influence on the architecture. Now, so it is something that we have to deal with as architects. One question would be, should we rather, in your opinion, or let me put that question first. There is this definition by Martin Fowler about software architecture, and what he says is software architecture is the decisions that are hard to change. And yeah. I sort of agree, because those fundamental decisions that we make are probably hard to change. Not sure whether it's like the level of definition, or whether I would call it a definition, but it's at least in something that we can observe, that the decisions that we make in the architecture are hard to change. Now, me or you as a software architect, that means that we have incomplete knowledge. We might even not know what we don't know, and because those are unknowable unknowns, we might not even be able to learn them and to facilitate that learning. But on the other hand, we have to make those decisions that are hard to revise and to change. So how can we even make decisions? How can we get out of this sort of hellhole, or this problem that we have there?
Yeah, I think that's an interesting one, because we are making decisions. The things that are interesting is the ones that we don't yet know which ones are going to be hard to change, because there's two things. One is we don't know necessarily what is going to change. So every kind of system has a set of things that are characteristic about it. In terms of its changes, what are the kinds of feature requests that people, over the years, will feature requests follow a particular pattern? Do they have a particular pattern, or that might they feel random? And sometimes with the older a system gets, potentially the more data you have about the kinds of changes this system experiences. Do people, if you are a system that deals with certain kinds of artifacts, certain items, in financial trading, the financial instruments that you're doing, how often do those change? For example, what are the things that are most frequently asked for? What are the, do people frequently ask for tweaks to the UI? Is that what normally happens? Are the standards to which you are conforming, are those stable or constantly evolving? Is the kind of other systems you need to connect to, is that normally the kind of thing? Is that, we need to connect to another class of system? Is that a normal kind of request, or is it an unusual request? Now, what I think is interesting is that involves knowledge about the future that we don't have. So when we make a number of decisions, we are not yet certain which of these we will want to change and which of these are hard to change. Now, those are two separate categories, because it turns out that if something is hard to change and we never need to change it, then it's not important to us. And we don't worry about it. It is still part of the architecture, but it doesn't get in our way. But the more that we need to change something, then the easier that should be in a good architecture. But again, we have the problem, we don't necessarily know that in advance. Now, by complete coincidence, I have on my desktop a book by Adam Thornhill, because I was showing it to somebody else the other day. So Adam Thornhill's Your Code is a Crime Scene, and he's since written another one. I find that this and other ideas of code analytics are very helpful, because what they do is they say, well, we can't necessarily predict the future, but what we can do is we can look at the past, and that can at least offer us a trend. So this is the interesting thing. When Martin made that observation, and it's similar to one that Grady Booch makes about software architecture being the significant set of design decisions, where significant is defined by cost of change. The problem is you don't know in advance which are the things you want to change and which are going to be hard, because sometimes you say, well, that's hard and we're never going to change it. That's the foundation of this system. If we need to change that, then effectively it's a different system. But there is this idea that the one thing we can do that might help us is to look to the past. And this is actually a curiously positive thing about legacy systems, which I don't think we take advantage enough of, is the fact that every legacy system, as long as people have been doing reasonably good version control, has a history. And that history is data. That history tells you what are the things that change, what are the things that do not change, what are the things that do not change because they're hard and therefore people avoid them, and that distorts the architecture around it because people are always working around. But what are the things that are hard to change but are stable because actually we never needed to change those? What are the things that are frequently changing? What are the things that change together? In other words, it allows us it doesn't necessarily allow us to predict the future, but it allows us plausible, reasonable projections. If I'm looking out the window at the moment, and if you ask me what is tomorrow's weather, I have not looked at the forecast, but there's a 75% chance that it's going to rain with some sunshine, because that's what I'm seeing today. And so therefore, I can basically say, based on the recent past, based on the trends of the past, we should be focusing our efforts on this part of the architecture to make it easier, because this is where all the changes happen. That other bit that we may struggle, we may say, oh, that's really complex, or we don't understand it. Maybe we deprioritize that, because you know what, we don't actually change a lot there. So in other words, we can actually ask the system, what do you think I should concentrate my effort on? People often worry about, like, how do I predict the future? How do I prioritize? But there's somebody in the room. Well, it's not a body. It's the existing system. Ask it. It's a very silent partner. It always receives the work. We always complain about it, but we never ask it. What are the things that you think we should be concentrating on? So first of all, I think what can help us is in trying to deal with what's going to be hard to change. Well, let's look at the past. If we have a past, that's already a clue. But I think also another element that we can do, so I think it's a very helpful way of looking at our system, because then we can start saying, oh, those things that are not the hard things to change, you know what, those are not, let's not worry about them as much. Those are not architectural. They're not going to be, they're not a big deal. And that's why pretty much every paradigm and every movement in software creation has always been about, well, let's separate things out. Let's loosen the coupling. Let's isolate changes. They're all about this. Each generation comes along and they try to reframe it and offer it in a new way, but often for the same reasons. It's just like, well, there are going to be changes, but we want to try and minimize the ones that are hard. There will be changes that are hard. If somebody said tomorrow, you know, that web-based system you got, the microservices system you've got, we're not going to use HTTP anymore. Oh, by the way, no more XML or JSON. That would be a huge, you've just taken away the foundation. And so, and people often don't consider those to be architecture. It's just like, that's probably because it's a bit like the air. I don't wake up in the morning and think, how's today's air going to be? It's just there. Or how's gravity today? I'm good. You know, that's not a thing that I ever worry about. It's become so invisible that we don't notice it. So there are those kinds of things, but there are the other ones we can ask about from the existing system. But I think the other way we can kind of, I don't want to say we can predict the future, but the other way we can get an idea of what might be significant is not necessarily, not to come, I used the term roadmap earlier on, but you know, whose 2019 roadmap contained global pandemic in 2020? One thing we can do is offer a real roadmap. In other words, real roadmaps have more than one road. And I think the job of the architect is not to tell you the way the future is going to be. It's to tell you the futures that might be. From where we are, here's our preferred path, but where might we go? What is reasonable within our current understanding? And that could change. And that also means that as we go through time, we're always looking out for, are we on this one or on this future? Which way do we think we're going? But it also makes you ask questions more rather than try and push ahead and force something that maybe is not the right answer. But that idea of being able to kind of look to the future and say, well, what are the possibilities? What are the things that we might feel comfortable with? But those things that we're not comfortable with, maybe we should list those as well, because there's always a chance. Just put them on the watch list, if you like. You know, here are things that we really don't know about, or, oh, I don't think that's going to happen, but, you know, it could do. Put that on the watch list. So in other words, for me, the role of architect is to have somebody who has this overview. And we normally think of that person as having an overview of the big picture view of the architecture. For me, it's bigger than that. It's the overview of what might be possible, what is probable, what is less probable, and how would I know? How do I know which future I'm going into? So for me, that's why I think that Martin's definition and Grady Boucher's definition about thinking about these things that are going to be hard, I think those are very useful because they remind us to keep our eyes open, to see what's hard and go, oh, that was harder than expected. That's interesting. Note that down because that might be important.
I think that's quite a powerful explanation of the role of the software architect, also to think about what might happen, what path you're on, and to sort of plan ahead. So I think that's great. I think I dug out an old presentation of yours, and I think it was also talking about the subject of uncertainty and so on. And I think it mentioned this idea of the last responsible moment. That also seems to be a useful tool to deal with uncertainty. So can you explain that and talk about how it's relevant to software architecture?
Yeah, so a lot of this goes, so there's this kind of idea about what we're doing when building a system. It's quite literally, we are codifying knowledge. We are encode, there's lots of different metaphors for how we should think about a software system. And one of the ones is that effectively we have it's a knowledge base. It's a collective knowledge base of the people who currently and in the past have worked on the system. And what they brought together is their individual knowledge, their knowledge about the tools and the technologies that they're using, the knowledge that they have about the domain that they are working in and the nature of the business. And what they're trying to do is create a system that represents this knowledge in a way that runs. You know, it's one of kind of like huge undertakings of humanity. When you look at it like that, it's quite cool. You know, what we're doing is applied executable philosophy. That's what's going on. You're trying to organize this knowledge. Now, you're up against this. You have the problems that the minute you get people together, they come from different sources. That's going to be a challenge. They have different views of the same, what might be the same facts. We also have lack of facts. There are things that we don't know, we're not sure about. And you're trying to bring all of these together. And normally you want to, people don't feel very comfortable with uncertainty. There's a lot of uncertainty in this. Or put another way, there's lots of things we don't know, and there's lots of things we're really not sure about what they will look like if we do know them. And then there's all the things that we don't know that we don't know. And we're trying to put this together. Now, that makes it a potentially high risk venture. You know, we're building a thing we don't really know. You know, it's that great realization of all adults is like, actually, you know, don't tell the children, but actually we don't know what we're doing any more than anybody else does. But sometimes we become confident, or we need to project confidence, and that becomes a business thing, because the business doesn't want to hear we're not sure. And that's why I say that for me, this idea of understanding the roads that you might be on is not to tell people, you know, shrug your shoulders and say we have no idea what we're doing. It's like, okay, here's a preferred path. This is how we imagine an ideal future. But here are also other possibilities that seem reasonable from where we are, some of which we control, and others of which are things that we don't control. You know, we don't actually control the market unless you happen to work for monopoly or near monopoly. You don't actually control the market. The market is something you respond to, but it is not something you dictate. So therefore, the future of your architecture is bound to the future of the business, is bound to the future of the market, and so on. We don't get to control that. So to make strong claims might make somebody else feel comfortable, but actually we're projecting a very false image. So there's this idea that there's a number of decisions that we need to take over time, and somebody wants us, normally, sometimes it's ourselves, sometimes we prefer to have confidence from ourselves, but sometimes it's somebody else in the business. Sometimes it's even the market. We need to project some kind of confidence. So this is where people come up with the plan, and the plan can refer to something in time, but it can also refer to structure. The plan is a structural, this is how the system's going to be. This is the layering. These are the technologies. This is where the developers will live in each. And we project that. And one of the great discoveries of human psychology is that we place a great deal, possibly too much, emphasis on how confident people are. Now, we mistake confidence for knowledge or competence. What we need to learn is, you know, if a scientist says, oh, this is very likely true, you know, there's a 95% probability, then they are being honest about that. When a politician says this is 100% the case, then we should be very cautious with that one. They're projecting confidence. The scientist is actually working within their needs. They're not stating beyond what they should feel comfortable with. Now, the reason this all ties into the last responsible moment is sometimes at a particular point in time, somebody wants an answer. There we are at the beginning of some cycle of development, and maybe we've got a major release plan in 6 months' time. And somebody says, in fact, this is from personal experience, somebody said, oh, we need to migrate the database. You know, we've just been given a system that was developed somewhere else. We are now the maintenance team. And in a few months' time, we need to deliver a new version, and we need to migrate the database. And we also need to add a form of replication, but we're not sure if the existing database or the next database technology supports that. And the whole shopping list of things. And so they said, Kevlin, what do you think? And I said, I don't know, because I don't know this stuff. This is not my area. And they kind of looked at me for a moment and said, well, it's not ours either. And they're looking for me, because I'm an outsider, to have some magical source of knowledge. And it's just like, I'm sorry, I don't know this better. But we need to say when everything is going to happen. And I said, well, do you know whether you're going to be able to migrate? You know, how much experience do you have in this new database? And one of the guys said, I have 1 week experience in this. Okay, you have 1 week experience in the technology. You're going to deliver it in a few months' time. And I said, how much knowledge do we have at this point to be able to make decisions about the detail of the replication model you're going to use, whether you're going to be able to use that or whether you're going to have to provide that externally? So you have 1 week, one person has 1 week's experience of this, and now you're going to try and put numbers on a line and tell me how the architecture should look. And I said, what's it going to look like if I draw it up on the board? And they said, we don't know. I said, right, that's I can't tell you anything here. And I said, so let's just do some estimation. When are we supposed to deliver? When are you guys supposed to deliver? And so they told me, and I said, right, and how long do you think it would take to do all these various things? And what's the worst case scenario? And I said, right, okay, let's work back. The worst case scenario is the longest one. Let's add a little bit of extra time to that. And I said, right. And it turns out that it was 2 months from when we were having the meeting. I said, right, that is the last responsible moment, because if you try and take a decision now, there is a possibility that it could be right. There's also a remarkably high probability that it's completely the wrong thing. You do not have enough knowledge to be able to take a responsible decision at this point. You can create a number, but it's fiction. And if you create the number and you stick to it, you may discover there are probabilities. Because one guy wanted to say, oh, I think this is all going to work out. And it's just like, yeah, maybe it will. But then again, maybe it won't. By what point will you have more knowledge? As you work with this database and the system, your knowledge will increase with time. So that's great, but you also need to have time to develop these things that you don't yet know. And there are 2 or 3 options you currently have, and one of them takes 1 week and the other takes 2 months. For example, that's a huge, huge difference. So how are we going to account for this? And I said, well, there is a point, the last responsible moment, which is, given our current state of knowledge, we don't know enough to make a responsible decision. But what we're going to do is, rather than take the decision, is take the decision to take the decision. In other words, 2 months from now is from our current perspective, the optimal point. Everybody will have 2 months more experience, as opposed to one person having 1 week. Everybody will have 2 months more experience. You'll have been able to spike this or do a simple prototype. You will arrive at that knowledge at that point with knowledge you didn't have before. And if it turns out that it's not the 2 month option, that's great. If it turns out it's the 1 week option, that's even better, because you've got enough time for both. And so that's the idea. You're trying to look at what point do all of our choices expire and force us down one particular choice, which may not be the right one. And so that's this idea of a kind of a meta planning. In other words, you're looking at what you don't know and you're trying to structure your schedule, but then that also tells you about structuring your system. You're using the fact that you don't yet know enough as a way of organizing what you're going to try and do. And you're using that constructively rather than running in fear and going, we don't know. Actually, sure, we don't know. By when do we need to know? And let's work towards that. And then we make the decision. And then, so that's, in other words, it's a 2-level model rather than a simple one. It involves a little more sophistication and reflection. But that's exactly, again, going back to what your observation about the role of architect having a different view. That's what they should be looking at. That's the view they need to take. They don't. It's not about just coming up with a shopping list of technologies. It is very much about this more complex level.
And I think it's a very powerful tool because, as you said, it means that we have more knowledge because more time passes. And I also found it quite interesting how you were referring to confidence, and how confidence is something that we are looking for, in particular us as consultants. I think it's, how should I put it, our role is, I think, different from scientists, because scientists have some hypothesis and then they prove it, and they have some work to back that up, while we are often asked for some advice, and depending on how much confidence we put in the advice, it might be followed or not, even though there might not be real data, and probably there isn't. However, what you're saying in a way is that this because we are seeking confidence, we will probably try to make decisions beforehand. And if we go to upper level management and we say, no, we are not going to make the decision right now because we don't know, that's quite the opposite of being confident, even though it makes perfect sense. As you mentioned, we have more knowledge, and the decision that we're making is going to be better, and there is no need to make the decision right away. But we appear to be more confident, in particular to, I guess, upper level management. So how do you deal with that? How do you make sure that you are still able to, that you still seem confident, or people at least in upper level management believe in what you're doing?
This goes for this bit, but like, people are the hardest systems we ever work with. You can show me, and it's like, oh yeah, look at this code. This is a real mess. This is really hard. Yeah, but have you seen the human beings? The human beings are way harder. We are just so difficult by comparison. And I think this does come down to a question of communication and the fact that we are and how we choose to communicate. So, there are certain things that people. So how do we make somebody else feel comfortable with the fact that we are saying we don't have one answer, or that we're saying, look, here are 3 possible pathways, and what I'm going to do, you need to, from that point of view, this is a difficult communication exercise, but what you're trying to do is to communicate that because you are showing the possibilities, that's more knowledge, as opposed to the narrow idea. In fact, my favorite saying, it's a good one for life, but I find it incredibly useful for software as well. Émile Auguste Chartier, there is nothing more dangerous than an idea when you have only one idea. And that idea, that issue is that people often get drawn into that. It's just like, yeah, he had this idea and he was really confident and he detailed it and he said, this is the way, let's follow him. I mean, this is the story of, this is the story of history. it's just like, yeah, okay, he's confident, he's projecting, I feel he feels good, therefore I feel good. He feels comfortable with this, and he's not giving us a choice. He's just saying, no, this is it. You don't get confused by anything. And so that's the appeal. If you can offer somebody a simple message with certainty, then it feels comfortable. So what we have to do is learn how to offer the idea that actually I'm going to show you more of the world and saying, okay, here's where we're likely headed. This is our desirable path. Here are the other possibilities. And what we've done, in other words, what you do is you show people the confidence that you project a different kind of confidence. At this point, we cannot, and you use words that are associated with responsibility, for example. So at this point, we can't, at this point, we don't feel it would be responsible because we lack experience in the technology, the market, the team, maybe there's all kinds of factors. Explain what those are, and therefore use terms that say it would not be responsible, it would be premature. We don't have enough knowledge yet to commit to this, but here are the possibilities as we see them, here are the paths. Okay, always never go beyond 3, that's too many for people, but definitely do more than 1. Say here's what we're thinking, and the way that we're going to structure it. So let's take that hypothesis idea. Is the way we're going to structure it is like, we are going to have a checkpoint, and people love checkpoints on plans, so turn those to your advantage. Basically say, what we've decided, what we've concluded is that this decision is not critical for another 3 months. And so we are going to review 1 month, 2 months, 3 months, this decision. And we have a side project to just do a little exploratory work to bring that decision forward. In other words, actually show that because you don't know, and we've created a plan around what we don't know, rather than saying, we're going to pretend we know, and therefore everything's going to happen exactly like this. You say, here are the things we can't be confident about, but here is the boundary by which we need to have made a decision, given what we currently know, and this is how we're going to get to it, and then the paths flow out from that. So, in other words, show that time has a structure. I think we like the idea that software architecture has a structure, but time has a structure as well, and I think we need to offer people that. And so, in other words, show a more complete map in that sense of time. And I think that's how you get around the communication barrier and avoid certain terms like, absolutes. We don't know. We have no idea. Unless you really do hit something, it's just like, honestly, we really couldn't tell you. But for other things, say, well, at this point, we don't yet know. Don't use the word yet. Just say, we don't know now, but here is the point at which, and this is what we're going to do to get there. And I think that when we restructure that, I think that's going to help. But again, people are hard. Different companies and different people will find different ways to communicate this, and you have to do a little bit of experimentation. But I think that's the skill here. I think that's the bit that we have not recognized as first class and need to promote that, to say, actually, that's how we should be talking.
So I think I like how you're saying that it's about communication. So it's about those soft skills that we should have as a software architect. And I took note of these two sort of keywords that you were talking about: responsibility and checkpoints. So that's a good way to frame something that is actually, well, a lack of knowledge, and frame it as a responsible behavior, which it actually is. And therefore, it's the same thing, just sort of communicated differently, which in this case is probably so very important. So what we are talking about so far is a lot about dealing with uncertainty and making up our minds and trying to stay away from decisions and these kinds of things. And I think this here is 20 years of extreme programming or so. And in extreme programming, there was this rule, or this famous Yagni rule, which says you ain't gonna need it. And that seems to be an advice about the very same thing. Basically, what this seems to say is, well, here is something that might happen in the future. And the answer that extreme programming seems to give is, you ain't gonna need it, so don't bother, and just build it as if it doesn't matter. So do you think that's a good principle, and that it's a good advice?
Yeah, but it has to be understood. I think that's the thing. That phrase is that, as with all sound bites, when they're taken, when we understand the origin story of it, it makes a lot more sense. And so, yes, actually, I think we're actually at 2021. I think we might actually be at the 25-year anniversary. I think XP was kind of 96, but it started coming out 96, 97. Started coming out to the world.
Then I confused the years. Yeah, that is very possible. It's just
you're probably thinking Agile Manifesto was 2000, and so we're hitting that mark. And the point about Yagni is not that it's a prediction of the future. When we say you ain't going to need it, we're not saying this will never ever happen. It's not a prediction, but it's phrased as a prediction. It's a nice soundbite. You ain't going to need it. It's just like, yeah, great. I'm going to act on that. What it is a kind of reminder of it's trying to remind you to focus on the present, because if you start obsessing about the future, one of the things I observed a number of years ago was that if you start saying, well, maybe we're going to need it, okay, that's possible. That's a very different thing, because maybe you're going to need something else as well. And it turns out that you are limited only by your imagination. And the more imaginative a team you have, the harder it will be to get any work done. It turns out that you make more progress if you're unimaginative, because if everybody can imagine more possibilities, you will be stuck chasing all of those possibilities. The less imagination you have, if you do have a simple view of the future, you may be surprised, but at least you didn't waste any time. So there is this idea that we just need to focus on, we don't know that we need it. Now, we might want it. Now, that's a slightly different thing. Need and want are very subtly confused words, but do we actually need it at this point? And somebody may offer justification, and that's fine. But then, is there another thing that we could say the same thing of? And why aren't we working on that? And if there's another thing that we could say, well, maybe this will be the case, why aren't we working on that? And the danger is that what we're actually doing is, rather than saving time in the future, we're stealing time from the present. And that's becomes the issue, is that the fact that we can imagine very strongly one possible future and we anchor on that, we get attached to it, means we're probably ignoring all the other things that could happen, and we're also ignoring the thing that we're supposed to be working on at the moment. And that's the thing, is that if with one team, I remember just seeing all these extra interfaces being added to their code. And actually what I found was not that they were adding, it's not the interfaces that I noticed, it was the empty methods. The methods were always empty. There's nothing wrong with implementing a method that is empty. That's fine. That's often a case, that not everything needs to be called back to do something, but it needs to have a placeholder there. But what I said is, when I looked at the method name, it was related to persistence. And I said, well, why is there nothing in here? You know, if I call this and I'm expecting something to happen, nothing's going to happen. In all of the cases that I've seen, are there any cases that do not have empty method bodies? And they said, no, they're all empty. And I said, well, this does nothing. And they said, well, we put this in to save time in the future for when this, if this feature gets introduced. And I said, well, how? So basically, you've sat around, you've added this, and how much time do you think you're going to save in future? And then they said, and I said, but you do realize, having seen this feature before, I said, you're actually missing a parameter here. Oh, so we should add it. And I said, no, but I've just told you that by the time the future arrives, you've now got a bigger maintenance load than you would have done if you were introducing it with full knowledge of what was required. And I said, why do you need this? Or why might you need it? And they described the situation. And I said, well, yeah, that might happen. But then again, it might not. And you're putting in a lot of work at the moment on this. And it doesn't work. It does nothing. You put a lot of work for code that actually does nothing. And they said, what do you suggest? And I said, get rid of it. That is your street. That is how you meet the future. You meet it with as little baggage as possible, not by adding lots of things, but sometimes by streamlining it. You know, you make a plane fly. If I want to make the plane go faster, then either I add a more powerful engine or I streamline. I make it lighter. I make it more aerodynamic. I make things get out of the way. And so what you want to do is make it so unassuming of this requirement that it is easy to add to, not that it eliminates new addition. And I think that's sometimes our false economy. We have this idea that how we're going to deal with uncertainty is by trying to embrace all of the uncertainties. But as I said, that set is huge if you've got a good imagination. The other way is to make it, rather than trying to avoid work or try to eliminate it, try to reduce it and say, when we come to add something, what is already there is well enough understood that it can be added to or easily changed. That's what we should be aiming for. And that, I think that idea is the one that I think we often miss. So that's where the Yagni thing is a reminder. It's that mindfulness message. Stay in the present. If you don't have enough work in the present, then start thinking about all these other possibilities. But honestly, that's not the way that most software development is you probably already have enough information in the present to do a good job. You just need to look at it more closely. And that it invites us to consider the present, and I'm going to say the past as well. Let's try and structure it according to that which we already know, and mark those other ideas, list them down, put them on a watch list. There's nothing wrong with speculating. Human beings this is one of our superpowers. We get to imagine futures, but that doesn't mean we should encode everything with one decision. We should just make a note of it and go, that's interesting. Let's note that down and see what happens with that. That's what we want to be doing. That's that big picture view. It's the big picture of time that we want to see. All these possibilities, one of them might come out. That's great. What would give us confidence in that? So that's the bit we need to be observing and noting down. That's what we should do with our speculation. Is acknowledge it, write it down, keep a watch, and then see how that influences things.
I think that's a very interesting view on that XP statement. So one final question: you were always talking about how humans and how humans are very important for software development, and maybe the sort of main challenge. And we are talking about uncertainty all the time. So uncertainty can stress people if you realize that you can't be sure about what's going to happen. That is certainly one source of stress. So how do you comfort them? How do you make sure that they enjoy working on the project?
Yeah, I think this is and I think a lot of us have experienced the being in a situation of uncertainty since last year at various levels. We've been running this planet-wide experiment on this, if you like. So yeah, people, it's a fairly standard observation that people would rather be wrong than uncertain. There's this curious thing about human beings that and this acknowledgement from Voltaire: uncertainty is an uncomfortable position, but certainty is an absurd one. And that's the challenge for us, is that we find comfort in certainty, but that's not necessarily and we'll do things to try and close off our knowledge, or to sort of say, no, I want it to be like this. So we have this problem. We're sort of saying, hey, uncertainty, it's normal, but also humans are not particularly good at this. So again, it goes back to this idea of helping people structure their time by seeing the possibilities, basically saying, okay, here's 3 ways this can go, you know, and showing what each one of those might look like, you know, whether it's a small piece of code, whether it's the larger scale of the architecture, whether it is how the market goes. In other words, what you do is you have a you don't solve the uncertainty problem. What you do is you make it clear that people you make it clear what each scenario might lead to. And if we look at this, it turns out that in one level, people are uncomfortable with uncertainty, but other people also enjoy it. We also enjoy it a lot. I mean, people watch sports, they play games. You know, how's this going to turn out? I don't know. You know, that's the point. That's why people enjoy that. We enjoy new experiences, whether it's watching a film or something like that. And we are uncertain of that. So in other words, it turns out humans are also very comfortable with uncertainty when it is presented in a structured way, and when we can see what is possible. And so I think that's really the kind of thing that we want to be showing people, is like, well, here are the things that might be possible. And if we're going to talk about, you know, sports and how people actually practice things in sport, is they do that. They practice. They should practice different scenarios. You know, for whatever sports ball game you're playing, there is a piece of the training which says, if this happens and you're in this position, try this. If this happens and you're in that position, try that. In other words, the idea of you acknowledge the scenarios, you list them out, and you say, and what do I need to do in each case? What is the context response that I do that? And you get better at the context responses. And you don't know which one is going to be appropriate, but when that context arises, you drop to the level of your training. You go, this is the way we go. And that's what we want to, that's probably the better way of offering it to people, is to sort of say, here are these different things. Let's get good at the, you know, let's understand what might be the case. So when that situation arises, it's just like, oh, yeah, we had this down as a possibility, or, you know, oh, I feel comfortable. I understand that this was not unforeseen. We didn't know that this was going to happen, but we didn't say it was never a possibility. We've acknowledged that it's done. So in other words, that's this idea of spreading out that knowledge and making it very clear. We can't tell you exactly what's going to happen, but here's a number of possibilities. People will already feel a familiarity and a comfort with that. So I mean, that's a very hard thing to do. I mean, I hope I'm not making it sound easier than it is, but I think it is the necessary thing to do. And I think that as humans, we are quite clearly capable of dealing with uncertainty. We just have a default preference in most cases to not have it.
Excellent. So thanks a lot. Thanks a lot for all the insights. I'm definitely looking forward to your keynote at Software Architecture Gathering. And we will show the link to the registration and the rebate code in the end credits. So thanks a lot, and I hope you have a great weekend. And
thank you very much,
everyone. I'm looking forward to your keynote. So
likewise. Yeah, have a good weekend.
Thanks.